Sorry, I forgot to open Docker. I'm using it. Okay, so while I wait for my computer to boot up and do things, I'm Ari. This is a terrible title for the talk I'm about to give. So let's come back to the title. We'll rewrite it later. And before I forget, because I always do this, if I don't have a slide that tells me who I am, I'm Ari. I'm a user pretty much everywhere. I write books. I live in San Francisco, and little known fact, I spent about 10 years as a professional comedian. I'm not that funny, and that's my dog. Oh. She might have to have eye surgery on Friday. Makes me sad. Okay, so I am one of the main authors of these 3 books. One of the cool things about those books, and also one of the most terrible things about those books, is that we keep them updated. So you can imagine the pain that we went through. All right, so before we get to rewriting the title, let's talk about smarter web applications. All right. Okay, so in our world, I would argue that this is true for everybody here, or at least most everybody here. Definitely in my world, data really matters. There's data everywhere. You turn on CNN, or the rough equivalent of what they have here in Spain, and people are always talking about big data, and they don't know what that means. But for us, when I talk about data, what I mean is it's really important for me and my business that we know who our users are, where they're coming from, how engaged is our audience. Are they opening our emails? Are they clicking on the buttons? How long are they spending on our site? Where are they coming from? What's the delta between today and last week, or last month, or 6 months ago? Even things like, does this content turn people off? This is all stuff that we look at, and we look at pretty intensely. The reason why we do that is because data, although data is really important to us, data doesn't mean anything unless there is action that's associated with that data. So what we're really looking to do is try to understand where our users are coming from, and how we can optimize the time that we have with them, be it one page, they're opening one page and they're there for a second, or they're a repeat reader of our intensely, amazingly awesome content-filled blog. Hint. Okay? But it doesn't matter, because the only thing that actually does matter is how can we engage our users to be more interactive with us, and that happens through action. So we like to look at what is actionable data. Today, what we do is we open up Google Analytics, or our custom analytics machine. We manually generate these reports. We look at things like I listed before. Are they clicking? Like, what buttons are they clicking on? How far down on the page do they scroll? If they make it to the bottom, are they actually? Is there any correlation between if you scroll super far down is there engagement the further down you go? Things like that. So then what we do is we'll take these ideas, we'll wrap them up into concrete components. That's a weird way of saying that. Concrete code? Yeah, okay. And then we'll deploy that, we'll test it, we'll run our A/B tests and see which button, what color of the button, or what call to action makes the most sense, what language makes the most sense, and then we'll deploy. And hopefully things go up, and if they don't go up, then we do that whole thing over again. And meanwhile, we have a day job. It takes so long. I'm not the only one who experiences this slide as like serious pain, right? Okay. That leads the question, maybe there's another way. We could, I don't know, hire a whole bunch of people, right? Super cheap. Use something like Mechanical Turk. Do you guys know what Mechanical Turk is? Mechanical Turk is a service that Amazon hosts that allows you to hire actual people to do actual work. So things like if you give them a whole bunch of images, identify if there are dogs in that image, and you can get people to do that, and they get like some number of cents per identification for photo. But that's really kind of a joke because we have machines, and machines can do this way better than we can. So today, rather than talk about data visualization, I don't have any idea why that we made that the title. We're going to talk kind of a little bit rough around the edges of machine learning. We're not really going to go too in depth. It's a little out of the scope to teach how to do machine learning. However, in order to even get to that part, we're going to talk about data science. So data science, I would argue, is exploring data through the story of our users. What is, like, as I mentioned like 4 times already, like what is the path that our users take and why are they taking that path? That is an example of a story for us. So computers are really awesome at doing things that we are really terrible at, like pattern matching. You can take a machine, you can run a whole bunch of data through that machine, and they'll spot patterns that you may never see for yourself. For instance, in this talk, in preparing for this talk, I found out that we have a lot of people who are in Australia who click on our buttons and convert past midnight that I never would have seen that. That's crazy. Midnight. And that's adjusted for their time. It's not our time. Okay, anyway. Computers are really awesome at automating repetitive tasks, like doing things like deployment or user tracking. And we can approach those problems algorithmically. Also, they're really fun at hosting LAN parties. And like I said, humans, we're not so good at doing things consistently. We're not so good at doing things quickly. We're definitely terrible at automating, especially telling jokes. So I insist that we use computers to do the hard stuff, the stuff that we don't want to do, so we can do the fun stuff. You know, like hang out in Barcelona. And maybe go to, was it Opium? Is that the name of the club? Opium Club? Opium Bar. Opium Bar, yeah. Okay, so anyway, I've gotten pretty far off topic here. Let's get back to actually Angular beers. That was not planned. Okay, wouldn't it rock? I think it would be really awesome if our applications could determine what to show at the right time to the right users. I like to think that what this helps us do is maximize the conversion rate of our application. That's really, like, that's the goal of this talk, and I would, again, argue that the goal for everyone here, everyone's professional career here, is to maximize user engagement. Also, I want to minimize the amount of effort that I expend on a daily basis. Don't tell this guy, because he's kind of a jerk. He's my boss. Okay, so I mentioned we were going to rewrite the title. Let's do that now. The title really should have been Building Smart Angular Components with Machine Learning. That's better, right? What? It's more, yeah. So in order to accomplish this, I argue there's a couple steps. What we have to do is we will create our components. We'll look at how our users are interacting with these components, and then we'll analyze that data, and we'll update the application, rendering, and update the application to match the user that is looking at our application by doing a little bit of prediction. So let's talk about a component. Let's say that we have a landing page, and that landing page has a bunch of components on it. And the components that we are really going to be interested in our demo talk are the ones for a landing page. So we might have like a description of what this landing page is, what we're trying to promote, some testimonials, have a sign-up box, and have maybe another sign-up box, maybe have like 30 testimonials that have like the scrolling sidebar, a little bit of call to action, like special offers, maybe if they make it all the way to the bottom that we say, oh, we'll give you a free book. And really what matters for us is, in this demo specifically, is what order those things show up for what user at what time on what continent, and who is that person, right? Like maybe teenage guys click on the call to action button at the top more than older nerdy white guys from Minnesota. That is such a weird segment to quote. Okay, in summertime. Okay. So step 2 is in this experiment is we want to set up an experiment to say at what order should we show our components. Where do people click and where do they leave? So in source code that will be opened after NG Europe, which is Tuesday, this is how you would do that in using this tool set. You set up your experiment. For the time being, I've taken the experiment and I've shrunk it down to 3 components. And basically what we want to do is we want to track we want our application to kind of automate itself, right? Like depending on where the IP is coming from, what the user agent is, maybe it's maybe the device is a mobile device running Opera browser. That's still around, right? Did I just date myself? Okay, thanks. All right, so that is, for instance, a demo, right? So we have these 3 components here, and we have these 3 components. We have sign up, testimonials, and description. In this somewhat relatively trivial demonstration, let's say that we track our users based on where they click on our page. So they might come down to the description and they might click a whole bunch of times on the description because they want to approve it. Anyway, so I promise this trivial example actually is pretty demonstrative of something that is more cool in just a minute. Anyway, so we set up our experiment and then we're done because our application will take care of itself. Hooray! So before we can actually call ourselves done, we want the experiment to take care of collecting data about users. So, and also the usage of the page. We want our components to maybe track scrolling. Maybe when our component renders, we want to track that. See how often this component renders. Maybe there's some correlation between that and how often somebody signs up and clicks and puts their email in. So, like I said, for the simple example, we're going to track those clicks and allow this to determine what order our application renders in. Oh, that one. Okay, so did a whole bunch of clicking on these 2. You might be like, oh, nothing's happening. This demo is totally broken. Well, when you render a page, it would be really odd if the boxes just started moving because you were interacting with them. So it's static. However, when we come back to that, we'll see that it's no longer static. Oh man, I totally gave away the surprise. Okay, see, our description box has now become like the most important element in that landing page. And what we're doing is we're tracking our users' information there, right? So for this simple example, we have a click event. This is just normal Angular 2. If you've never used Angular 2, this is just normal Angular 2. If you have used it, you've probably seen something like this before. The only thing that we are doing is we're using the wrapped experiment track function to track specific information both about the user and about the goals of this experiment. Okay, so now I was really excited. I wanted to jump ahead and say, oh, sweet, our testimonials, they're no longer really important. But I like that box. I hope they move up. Nope. Okay. So what this does is this notifies our server. But we haven't even talked about a server yet. So the backend setup for this guy. Or not the backend, the full stack setup for this guy. This demo has on the front end Angular 2, because we're Angular beers, and a little bit of custom JavaScript. In the backend, we're using kind of a lot of technologies. We're tying Google Analytics with our own custom backend analytics server, using a little bit of Spark and MongoDB to store our results, and some sweet Python. Whew. Okay, before I talk about how it's powered, I just totally blew through a whole bunch of stuff. If there are any questions, you're more than welcome to raise your hand. Don't throw anything at me because I care about this computer. Okay. Did you raise your hand? I looked down I was like, okay, sorry. Okay. So talking about exactly how machine learning, the algorithms that we're using is slightly outside of the scope of this talk. However, if you're interested in it, please tweet at me. I'm a user, or DM me on GitHub. Can you still do that? I think they took that feature away. Or write me an email. If you're interested in that, because I'm also really interested in teaching machine learning. Anyway, but for the scope of this talk, let's skip over the gritty details of that and talk just a little bit higher level. Basically what we have right now is we have a front end that is hooking up to a back end where we are storing a bunch of JavaScript events that are driven by our users. So like I said, maybe when our user scrolls down, if we have a ton of people scrolling down and spending a lot of time on the testimonial box, that means that testimonial box is probably pretty important. So we want to capture that usage. And you can do this with things like Google Analytics, which is why we tie into Google Analytics with this demo. So the way that I like to think about this is that our front end is hooked up to our back end, driven by user data. So what we want to do is we want to take all those events, we want to take all our user data and try to understand what's going on, try to understand why and how that data is being generated. So what we can do is we can take that data and we can build a model that generates goals based on information about our users that we're trying to derive. Like I said, is that testimonial box pretty important? Maybe it is. Then we're running our all these data points through a little bit of logistic regression. So we can. Oh man, I totally just jumped ahead. I'm sorry. Before we do that, in the next slide we'll talk about that. What we want to do is we want to look at the features that we're interested in. Like I said, where is our user coming from? At what time are they visiting us? Are they clicking on the right things? Are they not clicking on the right things? Are they clicking on the wrong things? Are they not clicking on the wrong things? I think I covered the clicking. Are they scrolling? How much time are they spending on the page? When does one component render over another component because the user is actually visiting it? We're doing lazy component rendering. And there's a whole bunch of stuff. There's a whole bunch of different features that we can take from the events that our users are generating and build a model around those to see if there are patterns there that we can we can dynamically render our application to capture and try to predict what the user is going to do when they land on our page. So when we do that, what we get is a model for higher user interactions. And what's really neat about this is before you serve the page, you can take that model and try to predict what your site should look like before you send it to the user based on a model that is in the real time, hand-wavy real time, being updated to try to reflect the user that is visiting your site at that moment. Wow, all that fell out of my mouth. Let me try that again. This is the coolest part. This is imagine if your application literally could rebuild itself for the person, could make a prediction, a maximizing prediction for you without you having to do any work. Thank you. Okay, so basically what we're doing is we're generating a predictive A/B testing based on real-time user data. This is the goal that I presented earlier. Our page will show the right information to the right user at the right time. Fancy. So imagine if we tracked other information. I mentioned a little bit about scrolling. That's something that we track. If you could track, if you had a heat map of what your user was trying to click on, and maybe you're tracking where their mouse is going, because maybe you're interested in knowing where they hover their mouse over. That's a bad example. It's the only one that's in my head right now. I need some more. Okay, cool. So what I like to call this is self-conversion maximization. That's the new buzzword. It will be going around the street, I'm sure, next month. You know where it came from. Okay, so let's talk about the future of let's say that this experiment is successful. What does that mean? What is the corollary? What can we project in the future? So what I want to do right now, let's take a trip 6 months in the future. Okay, come back. We're not going to go over there, although I'd really like to. I'm sure parts of Spain look like that. So looking beyond the simple example, imagine if we have lots of applications, not just one application, not this silly, where does our user click on, and how does that reflect what our website looks like? Let's imagine for a moment that we have a bunch of components. We have a bunch of different landing pages. Let's say that we have some testimonial components that have 3 boxes, and you can scroll and see more testimonials. Or you have a sign-up box with a sign-up button that says put your email in here, and you have another sign-up box that has we'll send you a free something if you put your email in here. Imagine if we have a whole bunch of apps doing this. If we could collect components that actually are hooked up through these experiments, we could collect information about our users and which one of those components actually converts the best for some given type of website. For the time being, I'm going to talk about our landing pages. We have ebook landing pages. Imagine if we had a whole bunch of components that we put on these ebook landing pages, and we could collect information about how those specific components relate to user conversions. We could pretty much just shirk the entire responsibility of building applications and just write the content maybe of our application. Although I kind of argue that we might not even have to do that, because you could do things like use natural language processing and just throw a bunch of words at a computer and have it pop out a website meanwhile, we're hanging out in the coast of Spain with our friends. Okay. So, any questions? I'll answer the one that I know everyone's been asking. I quit doing comedy for an ex-girlfriend. Any more? Okay, yeah? Yeah, so this... Let's see. Oh, no, it didn't start. Oh, well, that's why. Oh boy, did I just launch that on Amazon? No, I didn't, okay. Do you guys know what Jupyter is? So Jupyter is it's, what? Do you know what Jupyter is? Have you seen this page before? Has she? Does she know what Jupyter is? Do you need to go? I can. Sorry, I found that fun. Okay, so actually, this isn't going to show the algorithm that I'm using. I have to open a bunch of Java files to do that. So before I can, it's going to go up open source next week. So I can give you that then, or I can also after this talk, unless everybody wants to see Java. God, I don't want to do that. Okay, so yes, so basically what I'm doing in this really simple one user example is I'm taking those clicks and I'm storing geolocation, which for us right now is in one spot right here, and conversion tracking. So if I'm clicking on one component, I'm counting that as a point towards one component and a negative point towards the other components. So then I'm taking those features, the geo features, which are meaningless at this point, and the conversion features, and I have a 3-layer neural network, one hidden layer, an input layer, and an output layer, and I'm looking at which one of those components. I'm running some logistic regression with as we were talking about before, running a little bit of logistic regression, doing backpropagation to try to maximize, to see which one of those which one of these bars is more important than the other bar. And then I'm storing that, like I said, in MongoDB. Actually, right now I'm storing it in SQLite, for this demo, because I broke my Mongo earlier today in the GraphQL workshop. But then I would store that in MongoDB, and then when this page loads, I'm rendering this page from a server that is pulling that information and shoving that off to a really ugly directive. It's called the experiment directive right here, and then dynamically rendering our components based on the recommendations that come back from our server. Oh, that's in Java. It's in Java. Well, our experiment, I have one written in Python, which is our experiment one, and then using deep learning for J in Java. In Scala, actually. Java's a little uglier. But then again, so is Scala. Poor JVM. Does that answer your question? Yes. Okay.
Hey, all right, tell people what Jupyter is, because nobody answered yes.
What Jupyter is? Jupyter is an environment for running live code. It's a good point. So basically what Jupyter, oh no, I totally forgot. Basically what Jupyter gives us is the ability to oftentimes interact with, sorry, let me really quickly install this. Haha. Yeah, so basically what Jupyter gives us is the ability to execute live running code against a VM. In this case, I'm using a Python VM, but we could just as easily use, there's a bunch of different VMs we could use. In my notebook setup, I like using Lua, so we have Torch and Python 2 and 3. This is open source already. Okay. Hooray! Oh, my bad. Okay. Hooray! Okay, so this data is randomly generated using Faker. So we're probably going to see a whole bunch of countries that don't make any sense, like East Gobi, Queensland. What is Ewa? Is that a site? Is that a place? I guess it's in Tanzania. Okay. Okay, so this is a bunch of randomly generated, somewhat relatively correlated to our Google Analytics data. However, for respect to my company, I can't show that. Sorry. But this is basically what we do when we look at our data, is we take our Google Analytics data, we look at what components are being rendered the most, and how many are getting positive goals and negative goals. In this, I'm not showing any negative goals, just showing positive goals. We can show negative ones if we want. Yeah, it looks like Fu Yen does not convert very well. Okay. Okay. So some things that we do with our data is we'll often we'll group it by time of day. See ya. We'll group it by time of day and location about where people are at. You can see here this is all grouped by the 2000. That's funny. Anyway, this is all grouped by the day. We can do things like geo group by latitude and longitude to say, are you in this particular corridor? Something that I find really interesting is at what time of day are people on average converting in the week, converting on our site. So this is basically a chart of how we can look at something like that. We can see, for whatever reason, in our randomly generated data set that Fridays at 11:30 at night actually have a pretty good conversion rate. Oh, I totally lied. Monday has a really awesome one. We can also look at how many, this is another thing that we do oftentimes, is look at how many people convert, at what time of day for any given week are people converting. We can look at those raw numbers. You can see that, right here. Okay, sorry, I get really excited about this. Okay, so really that is not the right coupon code. So really this this talk is all about, or the really exciting part about this is the fact that we can now start generating applications that are, because of the super powerful rendering engine, dynamic rendering engine that Angular 2 offers us, especially with, that's not the right coupon code. That is also not the right coupon code. It's Angular beers. This one is no longer useful. Sorry. What do I didn't generate? Anyway, yeah, how cool is that? We could like build applications by not building applications, by just letting them build themselves. Holy cow. Okay, I'm really excited by it. It's going to go open source next week, so you guys can all get really excited by it too. And I have plans to hook it up also through React, so we can do the same thing. That's me. That's me.